Yeah. I see Gilbert's a thumbs up. Awesome. Thanks for confirming that. So I see people are still streaming in. Yeah. Still people are streaming in and they're waiting for more. Yeah. So before the rest of us can join, maybe in the chat box you can type for me where you're streaming in from. Myself, I'm streaming in from Kiambu. I hope you guys know Kiambu. It's a county in Kenya alongside Nairobi County. So yeah, I see a lot of you guys have showed up for this. Yeah. So I see Patrick is from Kiambu County. Gilbert is from Nairobi. Yeah. You can just type in where you're streaming in from as we wait for the rest of us to join. Yeah, I see Josie South Africa is from Kiambu. I don't know, maybe joined in from an company email or something, but that's okay as long as you get the contents right. Yeah, maybe on the chat box you guys can engage me where you guys streaming in from. So I see Cyrus Chege from Kiambu County. Awesome. I see Akuya from Kawangware, and you put a laughing emoji there. I mean, Kawangware is just that's awesome. I see so many of you guys, and our speakers just joined us. So without much further ado, as you guys are typing in where you're coming from, I see Vincent from Roysambu, my previous residence. Say hi to Roysambu people. Yeah, I see from Nairobi CBD, Gaturu. I see Barack Ouma from Kahawa. I mean, you guys, it's almost like everyone is joining in from the city, right? That's awesome. I was wishing to have some international audience, but that's okay. Maybe they'll join in later. So yeah, so today is on a Wednesday, on 18th of September, and I'm really glad to be here hosting this forum for you guys. And on behalf of CloudForce Sky community, my name is Evans Kivinji. That's what they call me. I'm a cloud engineer, AWS to be specific, and also a community builder. So I help running daily activities for CloudForce Sky. Yeah, that is getting in the new people and much more in the community. So as you guys already know, CloudForce Sky is a community of cloud enthusiasts, just like you. I mean, you joined here for a reason, right? So I'm pretty sure you are cloud enthusiasts. That's why you're right here with us. So later on during the meeting, links to socials will be sent. That is links to the CloudForce Sky community. You can go ahead and follow us for more information on how to join us and the webinars that we do have. So during the meeting, the links will be shared on the chat. Yeah, and feel free to join CloudForce Sky community. I'm glad you'll be eager and you will really benefit by joining in CloudForce Sky community. Okay, awesome. So going back to the chat, I can't see anyone else who has texted anything else. So Barak is from Kaha. Awesome, Barak. It's nice knowing that you're here with us. Yeah, and without taking much further time for speaker, I see it's already 8:21. So I'll go ahead and introduce our today's speaker. So today's speaker is Anthony Nzuki. Anthony Nzuki was one of my instructors during Restart, and I know a majority of you guys have joined Restart and have done it. Even if you haven't, kindly check on what Restart is all about, and feel free to join. It's a good thing for you if you're cloud enthusiast. You get to learn more about the AWS cloud. So Anthony Nzuki is a certified cloud engineer, yeah, first of all, and also he's a certified instructor, yeah. So Anthony Nzuki, feel at home, feel welcome to this forum. Anthony today will be guiding us on how to securely host MySQL, that is my SQL, as some of you would want to put it as. So you will be showing us how to host MySQL with Amazon Relational Database Service, that is Amazon RDS, and it will be in AWS VPC, which is a virtual private cloud. So without much further ado, I'll just go ahead and welcome Anthony Nzuki. I hope Anthony is on the call. Anthony, are you on the call? Sorry.
Am I audible?
Yeah, Anthony, you're audible. Unfortunately, my site was muted. Okay, I can hear you now.
Nice. Thank you so much. So, I know there are some of you who we've met one or another because of one reason or another in the different walks of life. And one thing that this community came from a learning program that we were in, and I'm glad to see that the community has really grown, and you're really impacting so many people out here. And yeah, looking forward to having an engaging session. I won't try to be an instructor per se, but please allow me to minimize my words, because I know I might speak a lot, and I'd actually want Evans to let me know how long would I have, so that I can really know how to balance my time, because I speak a lot. I usually speak a lot and speak fast at the same time.
Oh, awesome. Thanks for the heads up, Anthony.
Mm-hmm.
We're really expecting a lot from you, since
Mm-hmm.
you are like you tutored us, and you had a lot to say when you did so. So
Mm-hmm.
1 hour is what we allocated, but you
Yeah.
feel like your words can go more than that. I mean,
Yeah.
you're you're good. You're good to take the stage. Yeah.
Okay, thank you. Thank you so much, Evans, and much appreciated. So allow me to share my screen. I'm so accustomed to Teams that I hope I'll find my ways around it. So yes, to confirm once you have my screen.
Your screen is visible, Anthony, so you can proceed.
Okay. So once again, my name is Anthony Nzuki, and thank you, Evans, for the introduction. So my name is Anthony Nzuki, and I'll be the one presenting today, and we're going to talk about a very interesting topic, or a very interesting module that I love so much. And I didn't quite know that, even though I'm a mathematics person, I didn't quite know that I'd actually move along the database line, especially in the cloud, as much as I'm doing most of the cloud engineering roles. But I've had a keen interest in databases, to be specific. And specifically today, we are going to look at one of the most secure ways in which you can ideally host your database in the cloud. And much more of what I will be doing is an abstraction, or maybe a continuation of what a developer would do, or maybe a database, not a database administrator, but especially a data engineer who maybe is more invested on the developing side. And therefore, much more of what we're going to be doing is building an infrastructure that is going to help us have our databases being more secure, especially in the cloud platforms, because as we know, a database is a very intricate resource that needs to be hosted in an environment that is far much secure, because once the information is leaked out, then you know the kind of catastrophe that might be faced outside there. So once the data has been sent, either through a user input, it could be data that is coming from sensors or actually IoT devices. It could be logs that are streaming into our database for one reason or another, or maybe importing data from an external database. Or ideally, if you're working with an application and you're actually fetching data from your application's end through application programming interfaces, then we are going to then proceed from there so that we are able to know how do we ensure that our databases are actually fully secure. So much more what I'll be doing is I've already created an environment, but I will still go through it because creating it from scratch will actually take more time. And with the permission of our moderator, Evans, he could maybe, if there are questions and maybe I can't see the hands being raised, then you could definitely come on board and let me know once there's a question and maybe I didn't see any hand crop up. So allow me to proceed from there. So starting off, there are two aspects to this. And the first aspect is that depending on the kind of architecture that you want, it will be prudent for you to follow a more secure approach rather than just having an approach where you have a database that is already in the cloud. So with a VPC, because we know that AWS will definitely provide you with a VPC every time you log into your account, or so long as you have an AWS account, then we are saying that you're going to have some of the resources available to you. One of them will be a default VPC, and also they're accompanied by other subnets as well. So we are saying that as you now want to host your database into the cloud, it will be more prudent for you to have total control of all of your resources, so that at the end of the day, you are able to indeed be accountable for anything that happens, because you are in charge of your infrastructure. So we are going to use a VPC, where ideally this VPC is going to be our own VPC that we create, and with the resources that we are going to specify. Then once we have the VPC in place, then we can go ahead and create our database and make sure that our database is hosted on a resource that is going to make it more secure. So first things first, with the VPC, we have certain features of the VPC, and I believe that most of us here, being cloud enthusiasts, by now we have an understanding of the kind of infrastructure that we need to have, and also an understanding of the resources that we are going to use. So I don't know if this image is visible. So Evans, you can confirm if my image is visible here of an architecture diagram.
Yeah, your image is visible of AWS Cloud and the VPC. Yeah.
Yeah, thank you. So we are saying that we will need to essentially have a VPC that is going to actually house our entire infrastructure. And within this VPC, we are going to have a number of resources. One is basically for us an infrastructure that allows us to fully scale whenever we want to scale. In case anything happens to one of our availability zones, then we know that we are able to fail over the traffic of our or where the traffic is coming from to the next availability zone. So we are going to essentially need a VPC, and this VPC is going to have a few resources here and there, a few of them being subnets. We are going to have security groups, which are going to be our virtual firewalls for our EC2 instances. And for this case, we are going to actually use an EC2 instance that is going to act as our bastion host. So since we know that Amazon RDS is a fully managed service, so it's a managed service for that case, then we are saying that with a service like Amazon RDS, you do not have access to the underlying infrastructure. You don't have access to the EC2 instance that is running this Amazon RDS. So at the end of the day, then you will need to look for ways in which you can connect to that database so that you can essentially work with that database. So we are saying that you will have to go the private way, and the private way is ensuring that your RDS database is hosted in a private subnet of your choice. Remember, we are now dealing with resiliency here because we have two availability zones. So we can let it sit in anywhere we want. It could either be in private subnet 1 and also in private subnet 2. But I want us to have an idea in mind where we are leveraging redundancy at all points. So we are going to go for an architecture where we have a database that is essentially going to be multi-AZ, or that has this feature called multi-AZ. Why are we talking about multi-AZ? We're talking about multi-AZ because we will want to have a secondary location where if things go wrong, then AWS is able to spin up a secondary database instance in the target region that we want, so that it's always there at all times. In case anything happens, then we have that flexibility of failing over to another availability zone where we have our secondary instance seated there. So with that idea in mind, we will definitely need to have two availability zones. So even before you move ahead to creating an infrastructure for your database, you need to have certain reasonings in mind. One, do I need to leverage redundancy? Yes. What level of security do I need to enforce in my architecture? And therefore, that is going to warrant you to create a design that is going to tick or check all those boxes. So with this in mind, so we need to know that we are going to actually have a bastion host, which is ideally a server that is seated in the public subnet. It could be either in 1 or 2, or public subnet 1 or public subnet 2, but essentially we want it to connect directly to our database, and therefore that will warrant us to then finally expect an architecture diagram that looks like this. So first things first, same thing, first availability zone and second availability zone. And therefore, once we have our database instance, which is seated here in availability zone A, then through this multi-AZ feature that we have, then it's easier for us to, at any time, if anything goes wrong, then RDS being a managed service, and they notice that the database instance has faced some underlying issue that has caused the instance to actually not fully function or not function at all, then we AWS can spin up an extra secondary database instance that is going to sit in your second availability zone so that it's still able to perform its function. So how does this, then it begs the next question, then how does this bastion host then connect to the private subnet? Then we know that if you're dealing with AWS terms, then we are saying that you have a private subnet, which is essentially a subnet that does not have a route to the internet. And from this diagram, we can clearly see that we have another resource that we have to spin up, and that's what we call an internet gateway. So for those who are new in the cloud, we know that with an internet gateway, it allows us, or it allows anyone who is, let's say you're using your browser as a client and you're trying to access specific resources over the internet, and maybe the resources that we are talking about are your own resources. It might be a web server, it might be your own database, it could be a 3-tier architecture. Then the only way that anyone can actually get access to those or such resources or your resources will be through an internet gateway. And what makes a subnet public is essentially an internet gateway. So that route that is defined from the internet gateway all the way to the public subnet, so the subnet that is connected to it, then that means that these subnets that are in green will now have access to the internet. So those resources, so long as we have put in rules or networking rules that are going to allow traffic in and out of your resources in the public subnets, then traffic ideally at the end of the day should be allowed to flow into your architecture. But then we have a different resource which is called a private subnet. And what makes a subnet private? By virtue of it not having a route to the internet gateway, essentially. So we are saying that we might have our database in a private subnet and fully function, and people still have access to it through the internet, but we are going to have to use another resource, which is called a NAT gateway. And a NAT gateway basically will act like a jump server, if I'm going to use that code. I think that's the best word I would have actually used. It might be used like a jump server because we know that with a NAT gateway, it only sends outbound traffic. We are saying that you can actually use a NAT gateway to send outbound traffic. But at the end of the day, so long as we are going to leverage the use of a web server in this case, because we know that all traffic has to be routed to the internet through the NAT gateway, which is sending outbound traffic. But for you to then gain inbound traffic, then we know that we'll have to use a resource such as this bastion host that is now going to allow inbound traffic so that one is able to actually access it over the internet. So in this specific diagram, we are going to set everything up from scratch, straight from setting up the VPC, all the way to setting up your subnets, all the way to setting up your NAT gateways, which for this case will be used to perform some administrative control. But for now, we are saying that in terms of sending outbound traffic, we're not going to actually use the RDS database instance in this case because it's managed by AWS. So any management controls in terms of patching the instance, in terms of some of the operating system patches, all that is going to be the responsibility of AWS. So for this case, since we are not using our own managed server where we are hosting our database in, then that responsibility is not going to be our responsibility, but the responsibility of AWS. So at the end of the day, what's important is to ensure that this connection between the bastion host and the database instance is enforced. And how do we ensure that that specific connection is there? So the connection is actually going to be dependent on the security groups that we are going to have. So one is we're going to definitely have a security group for our web server. Second thing is we're going to have a security group for our RDS database instance. So we are saying that this database instance here with its security group, this security group is actually going to allow traffic that is coming from the web server. So we are saying that from the security group of the web server, sorry. So long as the traffic has been accepted by the security group of the web server, then ideally the security group of the database instance should allow that traffic, but it should traverse through port 3306 if you're dealing with MySQL. If you're dealing with PostgreSQL, that will be 5432, the default ports. So ideally, that's what we should have in mind, so that if traffic now is going to flow, then it's actually going to be allowed. As long as security group allows traffic here, then the database security group will be responsible of allowing any traffic that has been accessed by the security group of the web server and that has been allowed by the web server. So in that, we're able to connect to it, and by the end of the presentation, we should actually be able to at least install a full database in the client that allows us to actually use port 3306. So up to that point, before we look at me opening up Teams, I'm so sorry about that. In that, so does anyone have a question up to that point? Up to that point, does anyone maybe have a question? And am I speaking too fast? I tend to speak too fast. So worry not, I'll leave out a blog post that talks about all that I am essentially going to talk about. And by the end of the presentation, I will share with you the link to my blog post, and you'll actually be able to follow up on every step of what we'll be doing. So now that we have that in mind, we can go ahead and actually go to our management console and actually be able to spin up some resources here and there. So we are going to relate almost everything with what we've talked about in these architecture diagrams. But just as an extra token, we have a table of contents here, and it basically highlights every step of the way for you to move in a chronological order so that you're actually able to understand what you're going to be doing. So the first thing that you're going to be doing is, first of all, you're going to create a VPC. And with this VPC, it's actually going to allow us to spin up all these other resources, because a VPC is essentially your own isolated section in the cloud. It's more like your own cloud on-prem section, or you just your isolated section in the cloud where you'll get to launch your resources. So it's much more of your own private cloud, if I can use, or lack of a better word, it's much more of your own private cloud where you're going to launch your resources. So with this VPC, we are going to have to define the range of IP addresses that we will want to attach to our resources, because at the end of the day, we are saying that we are going to have our own isolated section, similar to what we have in an on-prem environment. In an on-prem environment, you'll ideally have servers that are placed on racks. You're going to have routers and switches. You are going to have an internet source. You're going to have cooling equipment, and so many other tools that you're going to use. At the end of the day, you will have to also assign a range of IP addresses to your resources. So the same thing is what you're going to do, and the same thing is what you're going to enforce. First of all, we make sure that we create our VPC and clearly stipulate our range of IP addresses, and we use classless interdomain routing classes to actually help us in doing that. Then once we have the VPC in place, then it's going to be important for us to initially set up security groups, because these security groups are going to be important because they act as our virtual firewalls that are going to actually safeguard our web server. It could be a web server, or it could just be a bastion host. It doesn't necessarily need to be a web server in this case, but we are actually saying that it could be an instance that is actually hosted in the public subnet. So with this security group, it's going to actually enforce some security for our EC2 instance that acts as the bastion host. At the same time, secure our RDS database instance that we are going to also create towards the end of the presentation. So once that has been set up, then we can then go back to our configurations and finish up on setting up the VPC, because the reason why we had to first initialize our VPC is so that we are able to specify that these security groups should reside in our VPC. Because at the end of the day, if they don't reside in our VPC, as we are creating these resources such as the bastion host and the other resources such as the subnets, then, or the EC2 instance, which will belong in a public subnet, then if we don't clearly stipulate that this security group should belong in that VPC, then in our list of options, as we are trying to secure our resources, then we're not going to find these instances because they are not within our VPC. So that's why we first of all have to create the VPC first, so that these security groups or everything that comes after creating the VPC is actually able to get hosted in our VPC. So once that has been enforced, then we are going to proceed with the steps of setting up our VPC, which will be essentially to create the subnets. Once we've created the subnets, we are going to ensure that we then capitalize on creating our internet gateway as well as creating our NAT gateway. Then after that, we are going to create route tables. And route tables are essentially just like our routers. So we know that a router will actually sit in between two networks. So we have the outer network where everyone from the internet is trying to make requests to our infrastructure, and we know that the other network is essentially the private network that we have. So once it's seated in between, then it's actually going to route traffic to if it's an on-prem environment, then we are going to route that traffic to our switches. And in this case, what mimics our switches? Subnets are going to mimic our switches. So we are saying that we are going to create route tables that are going to direct traffic to our switches. And what actually resonates to our switches, though they are not switches per se, but you have the idea in mind. So route tables are going to ensure that they define rules for where traffic is actually going to go to. So with the internet gateway in mind, we talked about the internet gateway letting the internet get in, then it means the route table. The route table has rules. Then the rules stipulate where should this traffic traverse to. So we'll need to set up route tables. Then through these route tables, we're also going to have associations so that if we have two routers in place, then this router should be able to direct traffic to a specific set of switches. Then the same thing applies. Then these route tables have to specify which resources or in which subnets do we actually route traffic to. So we are going to have to associate our subnets to either a public route table or also have that association between our private subnets with the private route table, so that the public route table will be responsible for routing any form of traffic to the public resources, and the private route table will be there solely to distribute traffic to private resources. Then ideally, we are going to also declare routes for where traffic is actually going to be traversing to. So that's the first bit. So we've created the VPC, we've created the subnets, the internet gateway, the NAT gateway, and their respective routes. So ideally, what we will have covered from step 1 to the end of step 3, from step 1 all the way to here, is essentially this specific image that we have, which is this. So all that I've talked about is us setting up the VPC in particular. So already we'll have enforced some form of security. So you might also choose to safeguard your subnets by the use of a network access control list, just to make sure that you harden your infrastructure enough. Okay. So once we have enforced that, then the next bit now will be for us to finish up on this second part. And this second part will entail us now just adding our Bastion host, which will definitely be a server. And now lastly, set up our security, set up our RDS database instance that will allow traffic that is coming from the server that is in the public subnet. So that part is now what you're going to cover in this step 4 all the way to step 6. So step 4 will entail creating an EC2 instance that is going to reside in our VPC, and that instance is going to connect to the database. So what do we need? We'll need to create a web server. It could be a web server, or it could still be an instance. You don't need to actually install either Apache Nginx or Microsoft IIS as our web server. So you can still run it directly. Then the other thing that you're going to do is you're going to have to configure an RDS database instance. So for this case, this is what is going to host our MySQL database, PostgreSQL database, Oracle database, or whether it's an IBM DB2 database. This is where we are going to actually set all that up. So the good thing with RDS being a managed service, we don't do the installation of the database software itself. We don't install MySQL. We don't install Postgres. We don't install Oracle. We don't install Microsoft SQL Server. We just state. So it being a managed service, I know some of you have heard about managed services. I know some of you have not heard about it, but we are saying with a service in the cloud that is managed, the underlying dirty work, let me call it dirty in quotes, the underlying dirty work is the responsibility of AWS. So you get to focus on setting up your configurations for your database, and voila, AWS is going to let you have your infrastructure set up. So what is going to happen here is we are going to have a database instance with all the configurations that we will want. We're going to actually look at that. The next, we're going to look at this unique feature here called a DB subnet group. So what is essentially a DB subnet group? we're going to go back to this image that we have here. Where is the image? The image is here. So what allows us to spin up a secondary database instance whenever the primary database instance goes down? So we are going to leverage the use of what of a resource called the database subnet group. Just like the name states, the subnet group essentially is, it allows us to specify which availability zones our secondary instance can actually sit in. So we are saying that we are going to have to specify the subnets that we will want to work with. And therefore, once we've, first of all, we'll have to state which availability zones should the subnet group work with. Then we are going to stipulate that it's availability zone A as well as availability zone B. Then after that, we are going to now ask questions. Then, since we have two subnets in availability zone A and also two subnets in availability zone B, then where or which specific subnets do you want to work with? Then we are going to clearly stipulate that we want that subnet group, which is just a grouping of the subnets, to specifically be private subnets. So what we are saying is you're going to stipulate to Amazon RDS as a service that we want to have a subnet group or a group of subnets where, in case something happens to the primary database instance, then remember the two subnets that we had actually enforced in our subnet group. Then once we declare the two subnets, then if anything happens to private subnet 1, then let's make sure that we work with the secondary database instance, and which is going to be in the next subnet that we are going to stipulate in the subnet group. So you can never set up a subnet group if you don't have a VPC. So as long as you want to enforce a multi-AZ kind of architecture, then you will definitely have to set up a VPC, and it has to at least have more than one availability zone for the sole reason of basically having a subnet group. So you don't have to clearly stipulate that you can even have 3 subnet groups if you wish to. And therefore, we are saying that you clearly have to stipulate which subnets do you want to work with, so that if anything happens to this subnet, to this database instance in availability zone A, then let the traffic of anyone who wants to access the database be routed to the next available database instance, which is the backup instance that AWS is going to take care of. So AWS is going to take care of replication. Are you together? AWS is going to take care of its deployment. So you don't have to have any custom scripts that you have to spin up and say that in case something happens or if the database instance goes down, then you have a custom script that is going to be executed that automatically creates like a secondary database instance, and definitely the replication process. You're not responsible for manually replicating all the data that is in the primary database to go to the secondary database. So I hope you see the beauty of working with managed services, because if you are dealing with a different setup where you're having a resource like a virtual machine or what we call an EC2 instance, and you manually host your database in that specific EC2 instance, you are going to have to be responsible of doing that. In case you want to fail over, you will have to think of mechanisms of how you can actually fail over. You can choose to take advantage of the auto-scaling groups. You'll have to just be creative with whatever you are doing. So at the end of the day, since you are dealing with a managed service such as RDS, how do you enforce multi-availability of your instance? It's only through ensuring that you have a subnet group, which is going to allow you to have that database instance or that secondary database instance that AWS is going to redeploy in the second availability zone that you're going to stipulate as you're creating the DB subnet group. So that's why I saw it as important to have a DB subnet group set up in place. Then next, we are going to create an Amazon RDS database instance that is going to run MySQL, because it's only in this database server, this database instance creation process where we are going to stipulate information about our subnet group. So there's no way we are going to create the database instance. There's no way we are going to create the database instance without the subnet group in place. So we are going to be very granular when we are trying to create this infrastructure. Then once we have done that, then why don't we then connect? So we are going to basically use Workbench because Workbench is one of the clients that will allow us to use MySQL. So it already has MySQL installed. For those who are running on Linux, I presume you'll still have to install MySQL in. Make sure that if you're using Ubuntu, you have to actually have MySQL in your system. If you're using any other distribution, you'll still have to have MySQL installed in your Linux operating system or distro for you to be able to connect to it. But for now, we are going to use Workbench. And with Workbench, you're able to do that. If you're dealing with something like PostgreSQL, then you're going to have to work with something like dbeaver, which is also a client that allows you to interact with the PostgreSQL. So this is purely MySQL related. So I think we can now get down to business, unless maybe someone has a question on the theoretical bit that I have taken you through. Anyone with a question? So everything is okay. So I think we can proceed. So Evans will let me know in case of anything. Thank you. So now I think we can now proceed with the creation process. So first things first, we have said that we have to set up our security groups. But before we set up our security group, we said that we'll have to set up our VPC. So what we are going to do is we are going to have to head over to the VPC console. And just to remind you, the VPC, we say that it's your own isolated section in the cloud where you get to launch your own resources. You might still choose to work with the default because we have some default VPCs created. So you can see in the US East region, there are 2 VPCs that are set up. And in the same region, we have 10 subnets. So now here, one of the VPCs, the default VPCs, mine is the second one. In the subnet section, I think the AWS already have 6 subnets set up. I have 4. In the root table, there are 2 default root tables created. So at the end of the day, you will never lack a default VPC because AWS is still going to offload you from creating network interfaces that are going to allow internet connectivity to your virtual machines. All those small details that we take for granted actually make the bigger part because AWS has taken care of all that and we do not have to set up such granular details because some of them have already been set up for us. So we are definitely going to move to the VPC console, and the first thing will be ideally to create a VPC, and that will warrant us to actually leverage our networking skills. So you will need to have an understanding of networking in terms of understanding IP addressing, having to understand how classless interdomain routing classes work. You'll need to know what are the range of public IP addresses that are allowed, what are the range of private IP addresses that are allowed. So what we only define is the name of your VPC. So here you might choose to go with any VPC name of your choice. So you can still choose, but remember that you have to name your VPCs in a way that you're going to remember. If you have a number of them, then you have to find the best naming convention that works for you, or maybe the set of standards that the organization has actually provided for you. So this is going to be the very first bit, naming your VPC, and you have to provide a CIDR block address. So that is a CIDR block address range. So what are the range of IP addresses that we can use? So I know some of you might ask, then why are we only putting in private IP addresses? So that's a very good question because AWS do not actually make it public, their range of public IP addresses, because they know if you are to have a very big company like Netflix who might be using a service like AWS, you letting AWS letting the public IP addresses get known, then someone will try to manipulate all those IP addresses, and you know how you can manipulate IP addresses. So AWS will never let anyone know the range of public IP addresses that they use, but you can still guess because at some point you get to use your 34 or something, 52 or something, but they will not publicize all of them and you won't know which public IP address belongs to who. And at the end of the day, they're also dynamically assigned. So they use you only have to specify private IP address ranges so that they are going to be attached to your resources as well, because these resources are going to communicate internally inside the VPC. There's that seamless communication between the resources that are inside your VPC. So you're going to have to put a range of public IP addresses. We know that we have some that start with 10.0 something. We know there are those that start with 192. Isn't that so? And we also have the others that start with 172 or 76. I think 172 if I'm not wrong. Dot something. So at the end of the day, you need to also understand what are the range of private IP addresses that you're going to use. So for our case, we might go with the 192.168.0.0/24/16. So ideally, this is just a simplified example that we mostly use even in class. And I know that we have an understanding of classless interdomain routing range of IP addresses. So this will actually provide us with 2 to the power of 32 minus 16. So ideally, it's supposed to provide us 2 to the power of 16 IP addresses, which is a big number, but you can adjust it to the number that suits you best. But for demoing purposes, I think we'll work with that. Then after that, you basically stick with the default tenancy. And after that, you just basically create your VPC. So since the VPC is already created, here it is. I had already created it beforehand with the same classless interdomain routing range of public IP addresses, or range of public addresses, sorry. So once we have the VPC in place, the next thing for us is, like we said, let's go back to the EC2 console, because we know in the EC2 console is where we get to launch our security groups. So we are going to have to set up 2 security groups. One of them being the security group, which is going to be the firewall for the instance that we are going to create. So this is our Bastion host or our Bastion server that will allow us to perform administrative control in our RDS database instance that is going to lie in the private subnet. So that is the security group, one of the security groups. The second security group that we are going to have to set up is the security group for our database instance that is going to reside in the private subnet. So we are going to have to set it up as well. So I've provided a arbitrary name. So the instance security group is ideally the security group or the firewall that is going to safeguard our instance. So at the end of the day, we've enforced some level of security where we've had a firewall that is going to safeguard our instance, and which is going to have rules that are going to be very strict in the sense that it determines which kind of traffic is allowed in our instance. So if you look at its inbound rules, let's just take a look at its inbound rules to have an understanding of what we are talking about. So one of the inbound rules is, and as you're setting it up, you just go and create the security group. You give it a name. You give it a name and specify in which VPC it's actually going to sit in. Then after that, we are definitely going to specify which kind of traffic we are going to allow. So your knowledge of networking is going to be very, very important. So as you are learning this, you need to have an understanding of what ports and protocols are to know which kind of traffic to allow, which kind of traffic to deny. So we have 2 kinds of traffic. We have HTTP traffic and we have SSH traffic. So the SSH traffic, since we are going to actually connect somewhere through SSH, because as you're connecting to each, we are going to connect through SSH. It's going to be important for us to mostly work with the SSH protocol. And since we're going to work with SSH keys, then at some point we are going to connect to our database using that specific SSH key. So SSH protocol is going to be important because it allows us to securely connect to our virtual machine, which is our EC2 instance, which we called server 1. So what kind of traffic do you want to allow? So you can choose to allow only your IP. You can choose to have a range of IP addresses that you might want to maybe connect to your EC2 instance. But ideally for our case, because of demoing purposes, we are still going to stick with anywhere, which is basically any IP address can essentially interact with our EC2 instance via SSH. So once you've connected to it via SSH, remember that as long as traffic has been allowed by this security group, then that traffic is allowed to get into our database instance. So at some point, so long as we've been able to SSH correctly and we provide these credentials to our SQL client, it's going to say that, hey, since you are allowed by the security group of the server, you are welcome. So long as you now pass through this door called port 3306, which allows database connections, especially in MySQL. So those are the inbound rules you're going to set up. So for this case, you're going to prioritize more with the SSH inbound rule, or the SSH traffic, or the SSH protocol. So once you have saved that, then you are going to go ahead and set up the next security group. And the next security group will be the security group for your database. You still have to safeguard your database. And also, as much as you're safeguarding, you still need to provide a leeway or a path that allows you to ideally connect to your database instance. So we'll have to set up this database security group, and these are its inbound rules. So one of the inbound rules, or the inbound rule that is most important, is you have to look for a protocol that allows specific traffic that is going to allow you to connect to your database instance. What kind of traffic is that? If you're dealing with MySQL or Amazon Aurora, know that Aurora is one of the proprietary products of AWS in terms of databases, and it allows relational databases, and its performance is even better than MySQL or Postgres. You can go for this option. If you're going to use Postgres, then you're going to have to go for this protocol. If you're using Oracle, you'll have to go for this protocol. If you're using something like IBM DB2, we know that it's not here, because some of you might be dealing with a database that is from IBM. Then what you basically do is you just have to come and provide the custom TCP, because it travels over TCP. Then under the port range, you'll have to provide the specific port range of IBM DB2. If we have any other database engine that is supported by RDS, but its protocol is not clearly defined here, then you can always choose custom TCP and specify its port range here, and it will still connect. So for our case, we are going to deal with MySQL, and therefore you'll see 3306, which is its port range, or the default port range, highlighted here. And therefore we are saying, then which source? What source should we take in? Should any IP address be allowed in our database? But we are saying only restrict the kind of traffic or IP addresses of ideally, let's say that let's allow any traffic that is allowed by the security group of the EC2 instance. Are we together? So since it allows traffic from specific IP addresses, and it has been allowed by this specific EC2 instance, then let those IP addresses that have already been allowed by this security group to also be allowed to travel through the MySQL protocol under 3306 port to be allowed into that database instance. So at the end of the day, you will have to come over here and just depending on the naming convention that you provide. So for my case, I know that security groups that I have end with an SG, then you're actually able to see the naming of the whichever instance that, or the instance security group that you had created prior. So you don't have to go so far. You just basically provide the name that you had already put up when you're setting up your instance security group. So for my case, it was called instance security group, and therefore that's why it's identified as SG blah 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 here. So once you've done that, so we basically save the rules. So now we need to go back to our table of contents, and we know that we've checked step 1 and we've checked step 2. The next step is now proceeding with setting up our VPC. So once that has been enforced, so what are we going to do now? We are going to have to go back to our console, go back to our VPC, and proceed with setting up our VPC. So we already set up our VPC. So the next part for us will be to create our subnets. So these subnets, we said that we are going to have public, we are going to have private subnets. And these subnets will contain a bunch of resources. So we'll need to specifically name them in a way that we'll remember that this subnet that has a route to the internet gateway, this is essentially a public subnet. This specific subnet that does not have a traffic or a traffic to the internet gateway, then this is a private subnet. So we are going to come over here, create subnets, and first things first, in everything you do, you will have to specify the VPC ID. Always work with the VPC that you created in the very first step, because these others are going to be the default VPCs, which might not align, because if you set this subnet in the wrong VPC, we are basically saying that you will have misconfigured at some point. So whenever you're going to try to troubleshoot, you'll notice that this subnet actually is not in your list of VPCs, or it's not actually in your VPC because you actually placed them in the wrong VPC. So in your options as you proceed, once you've created something and you want to specify the VPC, huko mbele, you'll not be able to access a specific subnet because you placed it in the wrong VPC. So once again, you have to specify the VPC that you are that you'll want your subnets to reside in. So ideally here, you're going to associate your subnets with this parent CIDR. So remember that you set up a CIDR block address range for your VPC starting with 192.168, where the first 2 octets are occupied by, what do we say? We said that the first 2 octets are occupied by the network, and these others are going to be dedicated for the host. So by the use of this subnet mask, I know that's a class for another day, but essentially what you are saying is you will still need to work with 192.168 because this specific CIDR block address range specifies that 192.168 is, or they are essentially the octets that you're going to be working with as you proceed forward. So even as you're setting up your CIDRs for your subnets, even as you see here, AWS have already given you a suggestion of the CIDR block ranges that you need to use, simply because they have gathered it from the IPv4 CIDR block for your VPC, which started with a 192.168. So you'll need to actually get in touch with your networking skills here and your IP addressing skills here. So you have to provide a name for your public subnet. So if it's a public subnet, ideally you're going to have to state that it's a public subnet. And remember, we had 2 public subnets. Going by our image here, if you look at this image here, we know that public subnet 1 is going to take in the 10.0.0.0/24. So ideally, even in our architecture here, we are still going to have our public subnet 1 take up a subnet CIDR block range of something close to 192.168.0.0/24. And you have to take note of the subnet mask that you're going to use, because this subnet mask is going to determine the number of IPs that are going to be allowed. So if you put in something like 20, then you can see that the range of IP addresses is going to actually increase. So the kind of CIDR block address range that you put in is going to determine the number of IP addresses that you can actually work with. So for an enterprise IT solution that works with so many resources, you might find yourself even working with more than 64 IP addresses. So you will need to touch base with the right kind of subnet mask that you want to work with. But for our case, we can simplify it and use 24, which allows us to have 256 IP addresses. So that is our very first CIDR block address. So we can still go ahead and set up the other subnets in place. So the first public subnet has a CIDR block address range of 192.168.00/24. So therefore, we're going to set up another subnet, which is a private subnet. So private subnet 1, because going back to our image here, you can see that public subnet 1 and private subnet 1 belong to the same availability zone. So you need to have your own visualization of how you want to set up this infrastructure. If you don't have any visualization, you can always use diagrams to actually help you in doing that. So always know that in availability zone A, we are going to have both a public subnet 1 and a private subnet 1. And we are going to set up redundancy, or make sure that we enforce redundancy by making sure that we have a public subnet 2 and a private subnet 2 in another availability zone. So going by our presentation here, we can clearly say that since subnet 1 has this specific CIDR block address range, then why don't we set up a few other subnets? Here we can set up private subnet 1, and it will have to reside in the same availability zone as the first one. So you have to take note, since we didn't actually specify here, since public subnet 1 is going to reside in US East 1A, then private subnet 1 has to reside in US East 1A. And therefore, we might give it another CIDR block address of 192.168.0 or .1.0/24. Then we'll then go ahead and create another third subnet. Know that this now is going to be the subnets that are going to belong to availability zone B. So first things first of all, prioritize the availability zone. For redundancy, we have to set up another public and private subnets in a different availability zone. So we are going to be forced here to set up a public subnet 2 in this availability zone and provide its CIDR block address range, which in this case is going to be 192.168.2.0. And I am assuming that a majority of us understand CIDR block addressing. If not, we will have to look some other time and specifically talk about CIDR block addressing and IP addressing in general. So that is going to be the other CIDR block address range for our subnet. Then finally, we are going to finish up with private subnet 2. Which is going to reside in the second availability zone. So remember we said that this public subnet 2 and private subnet 2 need to reside in the same availability zone. So US East 1B, and it's going to take up a CIDR block address range of 192.168.3.0/24. So I hope you've actually understood what we have done here. So take note, public subnet 1, it has a .0.0. Private subnet 1, it has a 1.0. Public subnet 2, it has a 2.0. Then the final one, it has a .3.0. Then after that has been done, you basically just create your subnet. So I've already created them beforehand. So we have private subnet 2, public subnet 1, public subnet 2, and private subnet 1. So we've already checked our box for subnets. So next, we are going to then go ahead and create, instead of having to go and create the root tables, I'd first of all go and create these internet gateways, because an internet gateway has to have a route to the public subnet. So there's no way we are going to create routes if we haven't created this resource, because we'll still be forced to create routes that determine which subnet is going to have a route to the internet gateway. Those are public subnets. So at the end of the day, we need to have an internet gateway present. So like I said earlier, an internet gateway is going to make your infrastructure go online. So without it, everything is private. So first things first, create an internet gateway, specify the name, and create it. Once you have created it, then the next course of action will be to attach it to a VPC. So it can still stand alone, but remember that it has to be attached to a VPC. If you don't attach it to a VPC, your respective subnets that have a route to the internet gateway won't be public anymore, because we don't have this internet gateway attached to your VPC. So ideally, you will have a problem there. So make sure that your internet gateway is attached and it has a state as attached to the VPC that you aspire to have, so which is the RDS VPC. So this internet gateway is attached to the RDS VPC which we created earlier. Then we'll also create a NAT gateway. If you want to create a NAT gateway, maybe you'll want to add more resources to your private subnets. Then ideally you'll still want to set up a NAT gateway. But for this case, we will not work with a NAT gateway per se, but you will still need it at some point. If you're going to have EC2 instances that reside in the private subnet, you might want to set up an application server. So instead of it sitting in the public subnet, then you can still create it in your private subnets and be able to set up specific routes that are going to ensure that it interacts with your web servers. So at the end of the day, NAT gateways are still going to be important, even though not in this specific use case. So next, we are going to go ahead and now create our route tables. Now, route tables, we say that they are synonymous to routers. So routers determine where traffic is going to traverse. So we're going to set up both a public and a private. You can still set up one main route table, which routes traffic to whichever, but just to have a clean environment that even if someone else comes and tries to interpret your architecture, it will be easier for them to actually understand your architecture because they can clearly see that it's indeed a clean architecture. So first things first, we are going to create a public route table. So ideally, you're going to click create route table, and you're going to have to specify the name for your route table. Once you specify the name for your route table, for us, we've called it a public. We have a public route table. And some of you will also give it their own name, so long as it will help you remember it as a public route table. Everything will always require you to specify whether you want to work with a default VPC or an RDS VPC. Then ideally, we're going to work with our own VPC, and then click create route table. So once we've set up our route table, here it is, the public route table. Then set up your own private route table using the same steps, using the create route table, give it a name, provide a VPC within which it's going to belong to. So now you have a router that is solely for routing private public traffic to public resources. We have a route table that is specifically designed to help in routing traffic to private resources, which is a private route table. So now we are going to then have to configure our router. We've just created our router. We've just availed our router. But now we have to provide routes for where this traffic has to go to. So with a public route table, we have to specify, now that you are stating to be a public route table, you are stating to be a router, then where or which switches do you want to connect to? So which subnets do you want to connect to, which are going to now form a mini network. So which mini network do you want this public route table to connect to? Then this other router, which is called the private route table, which other mini network do you want it to connect to? So this public route table, we are going to come to actions and perform a subnet association. Ideally, we are saying which subnets do you want to work with? Because we know that subnets are going to house our different resources. So we are basically saying this route table that we have called public, since it has a route to the internet, as long as traffic is flowing from the internet gateway, and now the router has been told, take that traffic from the internet gateway, pass it on to a web server. So that means that route table needs to know from my list who is a public subnet 1, who is a public subnet 2, and therefore we'll have to perform some editing. So edit our subnets associations and specifically make sure that we route or we associate public subnets to the public route table. So that means that you're going to have public subnet 1 and public subnet 2 all being associated with the public route table. Then we are going to also come over here under the private route table, click actions, and be able to look at the other association. What do we associate the private route table with? The private route table will definitely associate with private subnets. So we have private subnet 1 as well as private subnet 2. So ideally, that connection has been forged. So we know if you have traffic that is coming from the internet gateway, then the public route table knows that now this traffic that has come to the internet gateway, let me fetch it. Let me take it to the public subnets. Which public subnets according to the rules? Public subnet 1. So at the end of the day, we still have to edit routes. So we've only just stipulated that we want the public route table to only work with the public subnets. But now we still have to go ahead and specify which, sorry for that. So we have to go ahead and specify for this public subnet. So which kind of traffic does it pick? So we're saying it has to pick any traffic that is coming from the internet gateway and then take it to the subnets. Are we together? So that's the very first bit. So we have to go and edit the routes. So the first thing was edit subnet associations. We clearly stipulated that we want our route table, which is our router, to take traffic to either public subnet 1 or public subnet 2. But still, why don't we create those routes? Why don't we create those pathways of where traffic is going to flow to? So or basically set up wires. So now we are setting up wires in a nutshell. So this is where we are going to set up wires. So we are saying, let any traffic coming from anywhere over the internet, so long as it is coming from any address range, accept it. Now remember, what is going to filter this traffic at the end of the day is going to be our security group that is going to exist in our virtual machine. So as much as we are still accepting all traffic, because I know some of you might ask, then why are you allowing all traffic? It's still going to be filtered by the security group once we create the EC2 instance. So allow any traffic from anywhere. The target being the internet gateway. So we are saying let traffic that is coming from anywhere, from a target which is the internet gateway, let it be taken to our subnet associations. Are we together? So at the end of the day, what allows that traffic to move is actually going to be our route tables, which we have stipulated that as long as traffic is coming from the internet gateway from any source, then ideally, let it first of all interact with our internal services. And which internal services are we talking about? Let it interact with our public subnet 1 or public subnet 2, because we already have that association. So once we have set that up, we save the changes, and it's actually going to set up that route. Same for the private route table. Go to actions and edit the route. So we are saying that if the traffic is coming or the traffic involves the NAT gateway, so any form of traffic that is ideally from the NAT gateway, then let that traffic be routed to the private resources, because we've associated our private route table with the private subnets. So private subnets will only fetch traffic that is with the NAT gateways. That is in form of outbound traffic. I remember this time we're talking about outbound traffic from the private subnets all the way to the internet, because the NAT gateway will reside in the public subnet. So we are saying that any traffic from the private resources, private subnet 1, private subnet 2, then let them traverse through the NAT gateway. Then the NAT gateway will know what to do. Since it's in the public subnet, we know that we have a route from the public subnet all the way to the public route table, then from the public route table all the way to the internet gateway. So we need to enforce that route as well. And we have to specify the specific NAT gateway that we are going to use to allow us to do that. Then once that has been done, you save your changes. So ideally, you will now have a public router and a private router that has specific associations and specific routes, so that everything is now well-centered. So looking at our diagram now, if I could go back to my diagram. So if I could go back to my diagram, already all that we've talked about is all that we've set up here, apart from the instance and the security group. All that we've done has already been set up. So what are we going to now do? We are going to have to now finish up on this step. Let's create our database, and also let's create our EC2 instance, because we've already created this entire infrastructure. The last bit is now attaching our various resources to our respective subnets. So we are going to go ahead and now set up our EC2 instance. So we're going to have to go all the way to the EC2 console, which is the EC2 dashboard. And we are going to have to launch an instance now. So that instance is going to have a couple of configurations as we're setting up that specific EC2 instance. So first thing we're going to have to do is provide a name for our EC2 instance. So it could be our Bastion server. It could be our Bastion server as the name of our EC2 instance. And then we will choose an Amazon machine image, which is ideally a template that we are going to follow, or a template that AWS is going to use to launch this virtual machine. So it will contain, definitely it will contain the operating system. It's going to contain some of the pre-configured software, some of the pre-configured applications, if there are, and also some of the pre-configured or some of the configuration settings that are going to already be existing in that Amazon Linux or that operating system. So we're saying that that template is going to be in an AMI. So we are going to use an AMI that is Linux based for this case. So we are going to use an Amazon Linux 2023 AMI. Then after that, we are going to choose the instance type, which is ideally just what type of instance do you want? Do you want a bigger type of instance that has a bigger CPU, or the bigger cores of CPU that has bigger memory, that has bigger networking resources? But for this case, we are going to only stick with a smaller instance, so that for demoing purposes, you'll actually be able to figure it out. But at the end of the day, we're going to use an instance type that has one vCPU or one core of CPU that has 1 gigabyte of memory and at low networking features. Then after that, we are going to create a key pair. So the key pair will know that this is the SSH key that is going to allow us to connect to the EC2 instance. So the public key is going to be stored on the EC2 instance itself. Then the private key is what we download in our machine. So I was given a prompt for me to download a .pem key that I'm going to store securely in my local machine. So at the end of the day, I'll have to choose a key pair that I'm going to work with. Also, it's an additional security resource that we are having here. So you can always take advantage of it. Then next we have the network settings, and under network settings, here is where we are going to configure everything that involves networking. One is to specify the VPC. Which VPC do we want to work with? We want to work with the RDS VPC, the one that we created, and the one that has all that infrastructure that we've set up all this while. Then you're going to specify a subnet. So does this instance have to reside in the private subnet? I believe not, because we know that as long as it's in the public subnet, that's where we're going to interact with it via SSH. So it might reside in public subnet 1, it might reside in public subnet 2. Then we're going to auto-assign a public IP address. So ideally, we are going to click enable so that AWS auto-assigns a public IP address for us. So at the end of the day, if some of these steps here are not quite clear, you can always click the info section here. So with the info section, you're going to get more networking guidance, and you're going to see a number of options that you have. So connect to an instance that I can connect over the internet using SSH. You're going to get guidance on that. So our case will be create a bastion host for my RDS database. You even have a prompt here. Is this instance that you're trying to create a bastion host? Then follow this prompt, and AWS will give you directives on how you can set up this instance to act as a bastion host. So the steps I'm taking are ideally what is highlighted here. Once you click info on any of these options here. So for us, we are going to auto-assign public IP. Unless we have the bring your own IP, if you have your own IP that you have purchased from IANA, but since we have AWS managing public IP addresses and they charge us for these IP addresses, let them auto-assign them for us. Then instead of creating a security group, remember from the onset, we created a security group which reside in the lab, in the RDS VPC. Then we are going to select an existing security group. You can still create your own security group, and this is definitely going to reside in the VPC because the instance is actually residing in the VPC. So it makes sense to have this new security group residing in the same VPC. But for us to have a clean infrastructure, like we said, we can use an existing security group and clearly use the instance SG that we created from the onset. So we have that instance security group set up. Then ideally, we are going to have to configure storage for your root volume, or where your operating systems and initial software and configuration settings are going to reside. They're going to reside in your root volume. So ideally, we can let that stick with the default. If you want to add extra new volumes, you can always do so at your own peril. Then after that, we're not going to add any more. We're not going to add a user script that allows us to install a web server and such. Then we're going to go ahead and launch our instance. So the only unique thing we've done is making sure that we focus our energy on the network settings, because any slight change, any slight mistake, and everything goes to the drain. So once that has been set up, we are finally going to have our server running. Then once the server is running, then the last step that you're going to now follow is to set up our database. So this is also another intricate part where you're just going to search for Amazon RDS as a service. So here we have Amazon RDS as a service, and just click on RDS and you're going to be taken to the RDS console. So this is the entire RDS console. You get to create your database. And these are the steps, or these are the procedures that you're going to take. And you have to be very keen here, because also any slight mistake, you're not going to connect to your database at the end of the day. So you're going to confirm this once you are done. And this is the last step. I know Patrick is here to go for supper. I apologize, Patrick, if you're there. So let me finish up on this part. So we are going to create a database. So why don't we use the standard create? We are known for doing hard things. Let's stick to the standard create instead of the easy create. Nothing good comes easier. So let's use the standard create. And these are the engines that are supported by RDS. So remember that Amazon RDS allows you to launch relational database management systems. So one of the RDBMSs, or the relational database management engines, is MySQL, which I actively use. So you can use these other RDBMSs. We have Aurora, we have MariaDB, we have Postgres, we have Oracle, we have IBM DB2, we have Microsoft SQL Server. You get to choose which one you want to work with. So for our case, you're going to choose MySQL. And once you've chosen that, choose the specific version or the engine version that you want to work with. So for my case, I chose 8.034, which is the version that I am currently using. Then after that, you get to choose the template that you want to use. So for this case, since I'm using a free tier account, I look at the production. So if I have a production database, choose the production template. What does the production template contain? You can create a multi-AZ DB cluster. And what is a multi-AZ DB cluster? Create a DB cluster with a primary database instance and 2 readable standby DB instances. So by virtue of you going the production way, you're going to have 2 readable, a primary DB instance for read and writes, and you're going to have 2 readable standby DB instances, with each DB instance in a different AZ, and their sole responsibility is for high availability, data redundancy, and increases capacity to serve read workloads. So read workloads are going to be performed by these readable standby DB instances. So in production, to just offload a lot of, or just reduce the load on the database instance, then the standby database instances are going to be there to perform reads, and as well as transition to primary database instances if the primary database instance goes down at any point. So multi-AZ DB cluster is for that. So sisi watu wa free tier and dev.test, in the meantime, we could always choose dev or test, but the free tier only allows you to have a single database instance without thinking of backups or anything of that sort. So under dev or test, you still have the option to set these 3, whichever you choose. So the reason why we created Amazon, or what we called a DB subnet group, like I said earlier, we still haven't created it, but the DB subnet group will just contain your pair of subnets. So which subnets am I going to specify, so that if a standby database instance is going to be created, it's going to reside in the other subnet in the other availability zone for high availability and also data redundancy. So multi-AZ DB instance basically creates a standby database instance in a different AZ. So this one creates 2 readable standby DB instances, but for this it will create a single one. So we're going to go with multi-AZ DB instance if you are looking to leverage the multi-AZ feature that comes with RDS. But for us, you can stick to the free tier for demonstration purposes, where we are going to only have a single DB instance. Then we are going to provide the database name for our instance, because remember, we are essentially launching an instance that is going to host our MySQL database. So yes, you are launching an instance, but you are not actually responsible for the underlying steps that you're going to take. The kind of, you're only going to specify some of the instance details, but not the entire process of creating an instance. So here you provide the database instance name followed by the master username. So this is very important because this is also another level of security, the credentials or how you authenticate to your database. So you have to provide a master username. Take note of the master username, it's admin. Take note of the password, which is self-managed, because I don't want to use AWS Secrets Manager. I'll have to go for a self-managed password. So here I'm going to place the password for that specific database that I'm going to create. So whenever I want to authenticate into my database, these two are going to be very, very important, admin and the password that I set up. Then I'm going to have to confirm that password here. Once I've made the confirmation, then I'll need to select the type of instance that I want to work with. In production, we are going to use it as standard class or memory optimized. Then, next we're going to look at storage. So under storage, you're going to select which storage type you want to work with. And you have the option to choose a general purpose SSD and also set up the allocated storage. So the storage type is going to be important because it warrants or is actually going to be important in helping you understand which type of hard drive do you want to work with. Do you want to work with an SSD type of drive, which are known to be very fast, or do you want to work with hard disk type of drives? So you're going to have that flexibility to choose the type of hard drive that you want to work with. But those that are stated here are specifically SSD types of hard drives, which are best suited for databases. Then next, you'll get to choose auto scaling if you want to, but the most important part is on connectivity. Even though we are connecting to an EC2 instance, we do not have to click connect to an EC2 compute resource, because remember, the security groups will already help us determine which, as long as we have set up that security group that is going to allow traffic through port 3306, then that is enough to allow us to connect to the database as a Bastion host. So we don't need to connect to an EC2 compute resource. Let's take to do not connect to an EC2 compute resource, and we have to specify the VPC that we are going to work with, and also we are going to specify. Now look at the DB subnet group. So we are going to have to create the DB subnet group from the RDS console, but for now we are not going to set it up. We have already set it up beforehand. So you basically just specify the availability zone that you want to work with. Then from those availability zones, AWS will give you a list of subnets that are in those availability zones. You choose. So you're going to have to choose private subnets, because that's where you want your database to reside, in the private subnets. Then do you want them to be publicly accessible? So we are saying that we want our database to be publicly accessible. So this is the other important thing. Why would you want your database to be publicly accessible? Unless you're performing some testing or something. But in a production environment, we'll stick to having it not publicly accessible, because we have the Bastion host to allow us to essentially do that. So we're going to stick to no, that is not publicly accessible. Also enforcing more security for our RDS database. Then you have to choose a security group. You don't have to stick with the default. We are going to now have the other security group that we created, which is the database SG, which allows any traffic that is allowed by the security group of the Bastion host or the Bastion instance. It's going to automatically be accepted. So once that has been enforced, then at the end of the day, under availability zone, I don't have to specify the availability zone that my security group is going to reside in, because at the end of the day, we already stipulated as you're setting up the security group, it's going to belong in the RDS VPC. So by virtue of it belonging to the RDS VPC, then AWS will automatically decide where to have it. But remember also that it's still going to be availed in the availability zone where the database instance is located. So under availability zone, stick to no preference. Just create the just ensure that you specify the security group for your database, which we configured at the start. Then at the end of the day, if you want to leverage even more scalability, even more high availability, then you would better off work with an RDS proxy. So what is an RDS proxy? It sits in between your application and the database itself. And its work is to ensure that it basically uses the existing connections, because if an application is trying to connect to a database, Remember that the application needs to provide credentials, database accepts the credentials, then a connection is forged. So every time an application wants to connect, you can imagine the amount of load that is going to be experienced in the database, because every time you have to make these connections have to be made. So with an RDS proxy, what happens is that the application is first of all going to interact with the proxy, and once the application has already connected to the proxy, it's actually going to reuse existing connections that were already forged before. So you're going to have close to a million traffic that is supposed to actually head to your database. But first of all, it's actually going to leverage the RDS proxy that already has existing connections. Therefore, you'll find that close to a million connections are going to use the already existing connections, and RDS proxy will ensure that all this traffic reuses the existing connection to your database, therefore offloading all this workload to your database instance. So it's also advantageous, but it comes at a cost. Then the others, you're going to leave them as default. If you want to enforce even further security of who can actually interact with your database, we can actually go beyond the password and the username and the password, and still go to IAM database authentication measures as well as the passwords. Those who want to use Kerberos authentication, then you can definitely go through that route. But for our case, due to demonstration purposes, let's stick to using only a password and a username that will allow us to authenticate into the database from the server side now. So at the end of the day, RDS is not free. You'll have to pay for the database instance to run. You'll have to pay for storage, where we've deployed 20 GB to our database instance, and therefore you're going to actually incur around $13.98 for you to actually use Amazon RDS monthly. So that is the cost of running the Amazon RDS. So if you follow those prompts, then at the end of the day, you should be able to connect now to your database instance. So we have our Bastion host that allows us to do that. So because setting up an RDS database quite takes some time, it might take close to 5 minutes, to some it might take even 9 minutes, but ideally in 5 minutes you should have your Amazon RDS database running. So I also have my RDS database running, and what I'm going to fetch from this database instance is this, the endpoint. Remember, the database instance is managed by AWS, so I don't have access to the public IP address of that specific instance. The private IP address is definitely assigned to it, but how I can connect to it is ideally using this endpoint that has been created that maps to this specific database instance. So once I have this in mind, then I have everything. So long as I have the SSH key that I initially used to connect to the database, then I can still as well connect to the database. So the most important part now is connecting to the database. I know I've spoken a lot, so are there any questions, Evans, before I proceed?
Yeah.
Am I still there?
Yeah. Anthony, there are no.
Or did I lose track along the way?
Yeah, there are no questions. I can't see any questions in the chat.
Yeah.
Yeah, you can just proceed.
Okay, no worries.
Yeah.
So we've already set up the endpoint. So once you create the database, you now have access to the endpoint that you're going to use. So this endpoint allows us to connect to our database. So for myself, like I said, I'll work better with Workbench, where I already have a MySQL, the MySQL software already installed on my machine, and I'm actually able to interact with it using Workbench. So under Workbench, all of us will definitely have a local instance, basically highlighting that you are running your MySQL from your own machine. But you have this plus sign over here that allows you to add a connection. So if you want to now interact with your database now, you can always use this MySQL connection, and you'll actually be able to create your own connection. So how do we create our own connection? So we are going to use the Bastion server to connect to our database instance. So first things first, we have to provide a name for our connection. So our connection, we are going to call it RDS connection. Then the connection method, now we have a number of connection methods. We have local socket, LDAP, but we are only going to use, remember that we configured our Bastion host to use TCP at some point, and to allow TCP either through SSH, and at the end of the day to also use TCP. Or basically, once we are able to actually allow or move with SSH, which follows standard TCP, then we're going to use the security group of the Bastion host, which is going to allow traffic to actually move to the database instance. So here we are going to have to choose standard TCP over SSH because we are going to be dealing with the Bastion host, which already has an SSH key, another layer of security. So this is what we need to configure. What is the SSH host name? So the SSH host name in this case is going to be the IP address of the Bastion server. So the IP address of the Bastion server, we are going to actually fetch it from here, where we created our EC2 instance. So we are going to actually fetch its public IP address, and we are going to come over here and paste it in the SSH host name. Then we all know by now, if you're dealing with AWS, so long as you have an EC2 that's running, the default username is always EC2 user. The default username, even as you're SSHing into your normal instances, if you're a Linux user or if you're a Windows user, there on PuTTY, you're always required to key in a login as. You always say login as EC2 user. We don't have a password set up for our EC2 instance, so we are going to pass this part, but we authenticated using our SSH key, where we downloaded a private key file. So our private key file is in PEM. So please note that only .pem or .openssh key files are going to be allowed. So if you use .ppk for Microsoft Workbench, it does not understand .ppk. It only understands .pem or .openssh keys. So for this case, our SSH key, just a moment. Let me locate my SSH key, downloads. Here it is. So it's a .pem file. Please remember to work with a .pem file. Then what's the MySQL host name? So MySQL host name, remember we don't have an IP address for our database instance. So for this case, you are going to be forced to use our endpoint that we fetched once the database was created. So that is what you are going to use. So we are going to come over here and paste that specific endpoint. And then obviously, since we're dealing with MySQL, the default port is 3306. Then what is the username that we provided for our database? If you can remember, I said that you are going to use admin as our username. That was the name that we provided as we were setting up our RDS database instance. Then what was the password that we provided? Remember that you were supposed to provide a password, and that's why we said that we had an option to set up a password authentication, or use Kuberos, or maybe use IAM. So for our case, we only said that we are going to interact using a password authentication. So once that has been set, we can always save it in a vault. And then the final part is to confirm whether everything is correct. And now we can test our connection so that we get to know if we are able to connect to it or not. So successfully made the SQL connection. So ideally, whatever we have done here, the connection has been established successfully. So SSL enabled with the TLS. So far, we'll notice that our data as we connect to the instance is already encrypted. So once you click OK, we can then click OK, and then now we can authenticate into our RDS connection that we've just created. You can see the user name and the IP address for the Bastion host is already enforced. So we're just going to click at the RDS connection, and we'll have to wait. And eventually, if the connection is forged, we should essentially connect to our RDS And here is our RDS database. I know it has nothing so far, but we can still try and install a full database in our RDS instance. So long as the connection is, so if you made any mistakes, you essentially should not connect to your database. Are you together? If you made any mistakes in the security groups, we shouldn't have been able to actually connect to our instance the right way. If you're dealing with Linux, like I said, you will have to first of all authenticate to the Bastion host that is trying to connect to the Bastion host, install MySQL, and then you're going to have to add a command that allows you to connect to your database instance. So I'll provide that once we end the class. But in the meantime, this has successfully connected. So let's try opening an SQL script that we can try and with. For those who have been in Restart, I know we have interacted with this database. It's called the world database, the database that contains everything, every city, every country in the world. And we can try and import that SQL script. And once I run the SQL script, you can clearly see that the database is being set up as we speak. So it's inserting values and all the insertions are being enforced. So if there was an error, we wouldn't have been able to set all this up. So once the database has been fully set up, we can see under schemas in MySQL that we have the world database running. And therefore, we are able to actually perform or create our statements or queries using MySQL now as we move. So that was supposed to be my presentation. So sad that I've not even had a single question. Either I moved too fast or people got lost along the way or people fully understood every aspect of what I did. So yeah, I'll still leave the floor open for any question as we are populating our database here, which is supposed to be hosted on RDS. Yes. In the meantime, I'll pass the baton back to Evans.
Yeah, thank you so much, Anthony, for that awesome presentation. I saw Esther. Okay, I think it was a suggestion. Okay, someone was asking why you might have to change the VPC from a default one. I think just to customize. Someone answered is to customize the subnets and the route table and the security groups. Yeah, that was the only question that was asked.
Yeah, so you can. It's better to have that customization control whenever you're setting up your own custom VPC, because at the end of the day, you'll still want to have control over other resources, because you'll want to have the web application firewall at some point. You will want to have your VPC integrated with other services such as an unrelational database or a data lake such as Amazon S3. So I think customizing your own VPC is better because you can always spin up even more resources and integrate even more services in your VPC. So essentially, yeah.
Okay, so I feel like Manasseh has another question. Are you okay unmuting and maybe asking it out loud?
Okay.
Manasseh Mburu. Manasseh, I think. Okay. Before we can unmute, I think he has texted his question. If I may ask, can SAMP apply here since it also contains MySQL?
Setting up XAMPP. Okay, I haven't tried setting up XAMPP in my own VPC, but I think that's something I can maybe go research on. Or if anyone maybe has tried to enforce it with XAMPP, can actually come in and help us out. So for XAMPP, I think I'll need to maybe do my extra research and get to notice if I'm able to also set up my SQL on XAMPP and still be able to host it on Amazon VPC, all the same.
Yeah, I think Charles has another one. I think his hand is up.
Yeah.
Charles Ochieng, you can go. The floor
Yes, Charles.
Okay, thank you so much. I had a question on the connection of the RDS database. Say, for example, if I had a Linux machine, for example, Ubuntu machine. So if I wanted to, if I have my MySQL installed in my Ubuntu machine, will there be difference in the connection you made with your Windows machine in my case?
No. So I'm assuming that if you have your own Windows machine, assuming because I have WSL here, well, this is my own WSL that I interact with here once in a while, just to test out my Linux skills and all that. So I assume that maybe you are running your own Ubuntu, and at the end of the day, you'll have to authenticate into the instance. So long as you have authenticated into the instance, and we know that to authenticate in the instance, you have to provide a username, and also on top of it, provide a public IP of your choice, so an arbitrary IP address of your choice. So once you've authenticated to your instance, and for this case, maybe we can try authenticating to the instance that already exists. So allow me to try it out. SSH -I. Then we are going to have the SSH key. What is the name of my SSH key? Just a moment. RDS SSH key. So I'll come over here. So first things first, you have to definitely authenticate to the instance itself. So RDS SSH key.pem, and then I have to specify the EC2 user, then followed by @ and then the IP address. I have to follow it up with sudo. So the moment I authenticate to the instance itself, so I've already authenticated into the Bastion server. As you can see, it was assigned one of the private IP addresses from the address range that I had provided, meaning that you're already in the Bastion server itself. So here you can always use a command that is going to now allow you to essentially interact with your database, or basically interact with your database. So I had come up with there was a specific command that I had tried out. Yeah, here we are. So let us see. So let's just try and edit out some parts. So here I have to interchange this part with, let me just try it out. We're going to, then I'm going to explain about it. So this is the endpoint, because I don't have the name for the instance. I don't have the public IP address for the instance. It's going to be EC2-user at the endpoint value that I was able to fetch from Amazon RDS. Then under port 3306, then RDS endpoint -L, then I have to state my specific key file. So kindly let me paste in my key file to see if it's going to essentially work. Sorry, it was supposed to be SSH RDS SSH key dot so RDS SSH key dot /I, and I have to use sudo privileges. Just a second. So, but this is essentially the code that's supposed to work. Let me see if I'll. Warning: identity file RDS SSH key dot not accessible. Oh, I need to import the SSH key into the instance. So once I'm able to create, if I'm able to create an executable file, or if I'm able to create actually the file in the instance itself, and then change the mode to 400 to make it readable, then once I'm able to do that, but essentially this is the command that I'm supposed to use. So first of all, make sure that you have the key file with you. Make sure that you've actually made it readable within the instance. Then after that, you can ideally use this command. So I'm going to paste it in the chat, then you're going to try it out on your end. So what you need to do is just specify sorry about that. You just have to specify this specific command that you want to initialize SSH, and then -I to actually initialize you using the SSH key. then this is the part where you're going to actually be able to jump out of the Bastion server all the way to the configuration for your database instance. So at the end of the day, whatever you're going to need to, and I'll paste this on the chat. So whatever you need to just add is the SSH key once you've already imported it to your instance. Then after that, obviously the username is ec2-user, and obviously the other thing that you're going to need to add in is the DNS, or the endpoint that you are provided for your database to actually be connected to. So endpoint, actually this shouldn't be EC2 user, but the admin. Remember that we said that our database should have the username admin. So here you're going to change it with admin at this endpoint. Then let this part flow to show that you're actually connecting you through port 3306. And then have the name of your SSH key here. Then initialize it and use the SSH command alongside sudo. Once you've already created your EC2, once you've already created your SSH key and it's already in the instance itself and you've made it readable by changing the mode. Essentially, I hope you've gotten my point. I hope I've not spoken a lot of gibberish. I don't know. Is the point home for whoever asked the question? At the end of the day, so
yeah, the point.
Yeah. First of all, SSH into the instance, import the SSH key, change the mode of the SSH key, then use that specific command. Let me just post it on the chat so that you can have access to it. So, yeah. Any other question?
Okay, as you post that one to the chat, I think Lee has asked, should one solely rely on security groups, or can one use network ACLs for additional security?
Nice question. Yeah, you can even use both. You don't have to use one. You can always even take advantage of both NACLs and security groups to enforce even more security. Yeah? So, yeah, you can essentially use that as well.
Okay. I think there's another one. The project that we have just done, I think the one that we just showed us, load balancers important?
By all means, load balancers are very, very important. But remember, for this case, we are using an Amazon RDS database instance. We are creating an RDS database instance in the private subnet. But are we able to use an RDS database instance as our target for our load balancers? I believe not. Isn't that so? Because we know that targets for our load balancers can either be Lambda functions, depending on the load balancer that you're using. For an application load balancer, it will either be Lambda functions, EC2 instances. I think it also supports containers or IP addresses. So at the end of the day, you don't have access to the RDS database instance. So for this case, when connecting to the private resources, I doubt if you'll be able to use the application load balancer in this sense. But you would still use it on the public-facing resources. You would still use a load balancer on the public-facing resources to avoid exposing your Bastion hosts. So yeah, you would only use it on the public-facing resources, but not on the private-facing resources. Yeah, I think that will be my response. But is there anyone who would want to maybe chip in on that? Anyone who would want to chip in? But essentially, you would still use it on the public-facing, but on the private, would not have the RDS database instance as one of the targets for your application load balancer in this case. Yeah.
Yeah, I hope Kimari, that is answered. So there's another one, Gilbert. I wish you could unmute that up. Because he's asking, is it possible to take advantage of Amazon RDS custom with MySQL? Not sure what we mean.
What is RDS custom, Bwana Gilbert, my good friend?
Maybe you can unmute and talk about
it.
Hi, Anthony. I hope I'm audible.
Hi, good evening.
Sometimes back, I read something called RDS custom, whereby you can leverage the advantage of using the managed service and also having the option to customize or have access to the underlying infrastructure. That is the operating system. So ideally, that time few DBMS were being supported. So I was asking if currently MySQL is one of the options that can be leveraged in this option of RDS custom.
Wow, actually, this is something new. I haven't encountered this. I've actually gone to the console. I hope you're talking about this part, creating a custom engine version.
Yes, that one, exactly.
It's more or less this part. So I haven't gone over the custom engine versions, but I feel that this is an area I can also explore to also learn of more of this. So I can see it only supports Oracle and SQL Server. So I believe from this, we might conclude that it does not support MySQL apart from custom for Oracle and custom for SQL Server. But I think I'll still need to go and also look into it and see its differences from creating these custom engines and from the ones that we create from the console, the RDS console. But I'll leave the floor open for maybe someone who has worked with the custom engine versions, if there is in the call. But it's such a learning curve. Thank you on that end, Gilbert. Anyone? Okay, so I think Evans, this is something we'll need to look out for, and maybe on the next invite, I should be able to clearly distinguish between the two.
Has their hand raised? Maybe they have
Yeah.
an answer to that.
Yes, Barak.
Hi, Anthony. Am I audible?
Yes, you are.
Okay. I just wanted to ask a question. Okay, basically what you're trying to do, you're trying to take our SQL database on the cloud, right?
Yes.
And I just wanted to ask, since when we connect to a SQL database, you've already connected to RDS, what you've done, you've imported the script and you've executed it locally, right?
Yes, locally.
So I was trying to see, like, we know of AWS DMS or other data migration service, whereby you have your database locally, then you also move it to the cloud. Is there like a difference between DMS and what we are doing? And if there is a difference in terms of costs, which one is expensive? So, like when you configure DMS for sort of like continuous migration jobs, whereby you have maybe jobs running at a particular time, something like that, and you have like you're performing this database executions locally, and you've connected to RDS on real time. So like, is there like a cost difference since like you've hosted your RDS on an EC2 instance, and also for DMS, I think it's also the same. You basically have your DB on some VM or something, or some EC2 instance. So like, is there like sort of a cost when you look at both of them, like which one is cheaper, which one is a bit expensive? What will you go? Will you go for DMS, or will you do this like in terms of the workloads, the execution of things manually? Like which one has like sort of a less workload to the developer or maybe the system admin? Yeah, that's my question.
Okay. Well, in terms of cost implication, maybe I can start with the first part. Between the two. So for my case, yes, it's entirely possible to fully migrate your own database to a service like Amazon RDS directly using AWS DMS. So essentially, you will have to first of all identify your source database and where it's coming from, and at the end of the day, you will still need to actually look into the compatibility, because at the end of the day, so you know that DMS, for it to interact with a service like RDS, you have to look at compatibility when it comes to comparing between your local database and the target of where it's actually going. So my feeling is, when it comes to looking at the cost, there are so many costs that are going to be actually associated with it. One is whether you want to perform a full migration, or whether they're actually going to be minor, what do you call them? There's a name that AWS used to actually talk about the migrations. So there's either you perform a full load, and there are those incremental loads that you're actually able to perform as you're migrating. So I feel like whenever you're performing a full load, if it's a full load, because at some point you might be wanting to maybe add some incremental data to whatever you already have. So incremental won't be actually charged more, but for the full load, I feel like you're going to actually be charged more. So obviously you're going to also face additional costs when it comes to storage, because at the end of the day, storage is also going to be a very important key factor, in the sense that you're also going to have a DMS instance that is going to facilitate the movement. So with Amazon, whenever you're dealing with Amazon DMS, you can't avoid charges in terms of the database migration service, because there's an instance that is running and that is enforcing transfer of data. There's also, whether it's a full load or it's partial load that you want to perform, those are charges that you have to have in your mind. But at the end of the day, if we are dealing directly with maybe importing it locally to Amazon RDS, what are the charges that you're going to expect? You're going to, first of all, because RDS is already running on 2, whether you're performing migration through DMS, RDS is still running. RDS, you're still getting charged for running that database instance alongside the storage for that specific RDS. Whenever you're using AWS DMS for migrating, you're still going to be charged the charges for that specific instance and its instance type. You're also going to be charged for the storage of that EC2 instance. And therefore, also as you're performing the migrations, if it's a full load and you're also dealing with partial load, full load will also incur a lot of charges, because at the end of the day, the instance is running for long. So I feel like using DMS will actually bear a bigger price as compared to us doing it locally here and actually having to use a Bastion server. Because for the Bastion server, so long as we look at the right payment plan for that EC2 instance, so long as we are maybe migrating it with a smaller specific instance, yes, you're still going to be charged for that instance. But I feel like for a DMS, that is for an instance that is running DMS, you're going to be charged more, because we don't have any data transfer charges when you're dealing with this specific architecture, where we are dealing with a Bastion host, where we are getting to migrate the full database directly from our local machine to AWS. But I assume, I'm not quite sure about DMS, but I'm sure that there are some data transfer charges that are going to be charged, whether you're performing a full load or you're doing a partial load, or you're transferring data from your own machine or from wherever you're actually fetching it from to AWS. Yeah, so I feel like it will depend, but the DMS side is going to be a bit more expensive, especially if you're going to be performing incremental loads to your database over time. Yeah. Any other question? Thank you for the questions. I'm loving it. At least I know that people are actually following through. Any other question? So I'll be posting a link to my blog of all the steps that I've talked about. I know I have spoken quite very fast, but allow me to share with you the link to my blog post, so you can always check it out. And if you have any scrutiny, if you feel you want to add anything on top of it, you can always add it up and we can always have that discussion. So if there are no further questions, can you share it in the WhatsApp group? I'm currently not on the WhatsApp group, but yeah, I'll be hoping I'll be added, and also I'll share it with Eric and Patrick as well. Where can we apply OpenVPN in that connection to the DB? Where can we apply OpenVPN? Where can we apply OpenVPN? That's a good question. Now, let me think of it, Fantas. I presume you can use OpenVPN by installing it on an instance, because I also did a small project on setting up your own VPN server. So instead of setting up, or let's just say this, instead of setting up the Bastion host without just the Bastion hosts on it alone, why don't we ensure that we create the OpenVPN server, or maybe configure that instance with the OpenVPN software. So we use OpenVPN, set up the public key infrastructure on the instance. Are you together? So once we've actually set up the public infrastructure on the instance and we've actually installed the OpenVPN software, then all you're going to be trying to do is this. So long as you want to make sure that you're sending data to your database, then first things first is that once you're going to actually set up the OpenVPN software, and basically we have that VPN service running on the Bastion host, then we're able to enforce that security by using OpenVPN, which is actually going to be an extra security that you're going to actually add. So yeah, essentially we're actually going to have to install an OpenVPN on the Bastion server itself. And therefore any migrations happening locally from whichever, that is going to be encrypted by default as we use that OpenVPN server now, which is hosted or that OpenVPN server that is hosted on the Bastion host to allow connections to the database directly. So yeah, I'd install the OpenVPN to that database Bastion server that is in the public subnet.
Yeah, so thank you so much, Anthony, for the insights. That was so much helpful. And I hope you guys learned something. I saw your PC went off or something. Yeah, I hope you're okay. That was an amazing session. Yeah, Liz, I totally agree. That was such an amazing session. And we look forward to hosting you next. Yeah, for those of us that are willing to join CloudForce Sky, just go to cloudforcesky.com/membership, and then you will get the instructions on how to join. So without much further ado, I see we are way past time, but that's okay. We had to get all these insights from Anthony. If anyone has any comments before we wind it down, this is your chance. But yeah, that was an amazing session. Thank you so much, Anthony. And from our side as CloudForce Sky, it's a goodbye for now. And we'll see you next in the upcoming webinars. Thank you so much for joining us, and have a good night.
Good night. Thank you.